hello, good morning, good afternoon, good evening, wherever you're joining from. A big hello and welcome from Zero Waste Europe. My name is Jack McQuibben. I'm the Cities Program Coordinator here, and thank you so much for joining our webinar on chemical recycling today, what it is and does it fit into the circular economy. We've got three really fantastic speakers lined up, really grateful to have them here. So yeah, it should be a fantastic 90 minutes or so. A bit of introduction to how the webinar is going to work first, and to who we are at Zero Waste Europe. So at Zero Waste Europe, we're an NGO based in Brussels, but we work across Europe, working to turn the vision and the dream of a circular economy and a zero waste Europe into reality. Our Zero Waste Europe live webinar series brings together experts from across the continent and beyond to discuss critical themes, policies and trends surrounding zero waste and the circular economy today. And my role here at Zero Waste Europe, I coordinate our cities program, where we work with nearly 400 municipalities across Europe to help guide and support and really help the transition of zero waste at the local level, pushing for ambitious waste legislation here in Brussels too, and supporting our members to deliver zero waste strategies on the ground. The webinar today, we've got, as I mentioned, three fantastic speakers. We'll start with Jean-Marc Simon, the Executive Director of Zero Waste Europe first, and then we'll have a dedicated Q&A with him for 10 minutes, and then we'll go on to our second speaker, Carlos Monreal, again, and then that'll be followed by a 10-minute Q&A, and then that'll be repeated for a third time with Rosina Petrova from the European Commission, again, followed by a Q&A as well. And so, first and foremost, I'd like to give a special actual mention. We have a live connection with Vilnius Gediminas Technical University, and a special thank you to Dr. Ausra Zygmuntien, and I'm 100% sure I pronounced that wrong, so apologies, but thank you so much, the Director of the Faculty of Environmental Engineering there, for helping set this up in partnership with Demantas Tasavicius, from our Director of our member in Lithuania, in Economica. A couple of logistical points, so apologies if you're watching this on recording. We have a platform here, a technical platform, that limits our capacity to 100, and we had over 280 participants sign up. So we thank you for those who are watching live, and also those who are watching the recording, obviously. Thank you for submitting that as well. And the final logistical point from us, we apologize, our actual email server has very helpfully been down today. So if you've emailed to contact us, that's why we haven't responded. So apologies for that. Enough logistics, we can get started with the good content. So chemical recycling it's a new buzzword. We keep hearing about it from different stakeholders, whether that's industry or policy officers or concerned activists on the ground. And Zero Waste Europe here, we recently released a study to shed some light on the topic. With this webinar though, we're hoping to really move a step further and trying to understand what we refer to when we say chemical recycling. What are its pros and its cons, and whether it can fit within a circular economy. The speakers represent here today three different angles within this discussion. Industry, already testing chemical recycling, the European Commission Directorate General for Environment, working on waste management, and the environmental NGO sector evaluating chemical recycling's suitability to fit within a circular economy. And some of the key questions we'll discuss today really focus, like I mentioned, the definition of chemical recycling, what it is practically. Is it really recycling as we define it? A comparative analysis with mechanical recycling, the current state of the technology surrounding chemical recycling, including its advantages and drawbacks, and the policy status and the challenges surrounding this currently. And as I mentioned, there'll be numerous opportunities to engage with a Q&A with the speakers, and we do this via the Q&A box that you'll see at the bottom, the function here at the bottom of the Zoom chat. And so please submit your questions via this function here. We also have a chat box which you'll see next to this, where we'll be sort of implementing, or sort of putting links into the content that the speakers mentioned here. But it'd be great also if you're on the call to introduce yourselves via the chat box as well. We'd love to get to know who's with us here today. So without further ado, let me pass over to our first speaker, Jean-Marc Simon, the Executive Director here at Zero Waste Europe. He's been a leading voice for zero waste in Europe since 2007 as a regular keynote speaker in many industry and NGO meetings in Brussels, but also locally and globally as well. He's a member of the steering committee of the Break Free from Plastics movement. Among many other publications, he has authored the Zero Waste Master Plan for Cities, as well as the book Zero Waste, How to Reactivate the Economy Without Trashing the Planet. With a background in economics, he has more than 10 years of experience working in governmental and non-governmental organizations in the fields of good governance, new economics, social justice, and the environment. So, excitingly hand over to Jean-Marc for our first presentation.
Right. All right. So, hello everyone. Thank you, Jack. Thank you for setting this up. I think it's very timely to have this webinar, and I'm very thankful that we have this variety of views today here from the industry and from the legislators as well. And as Jack said, this is quite a buzzword today in Europe. And without further ado, I will start my presentation. And the reason why we actually already last year we started looking at chemical recycling with interest. And all of that fortified basically in a study that we published in August called El Dorado of Chemical Recycling. And yeah, just disclaimer, the name of El Dorado kind of came at the end when we actually saw the results of our research. What we found, well, the motivation behind the study was that we were seeing that more and more around the world, chemical recycling was becoming a buzzword. When I was talking to different industry people like investors, etc., it seemed to be a kind of different understanding or a different expectation of what chemical recycling was going to bring in the topic of, on the big topic of plastic pollution. And I think they was giving the false expectation that this was kind of a solution to all the problems of plastic pollution. And we saw that there's this mounting interest, but because of this lack or this different understanding, we decided to actually look into this more into detail. Because at Zero Waste Europe, we have been looking into pyrolysis and gasification already for some years and seeing, well, the performance of these technologies. But the moment that that was kind of like put into the frame of chemical recycling, we were a bit like interested and to a certain extent worried about what impact that would have. So what we found out in this study was that actually there's not a technology called chemical recycling. We found that at least to categorize them, we had three, which are the solvent-based purification, chemical depolymerization, and thermal depolymerization and cracking, grosso modo. And again, there's different ways to interpret this, but in the graph here on the right that you can find in the study, basically the difference between these technologies is that once separate collection has taken place and the sorting has taken place, be it for monostreams, plastic monostreams or plastic mix, you can turn this stream into, through mechanical recycling. That could be a plastic to plastic. You could actually do polymer to polymer recycling, which is the solvent-based purification. That is here, I'm pointing at now with the cursor. You could also have chemical depolymerization, which is kind of monomer to monomer. And it's this that goes from monostreams to monomers. Or you can actually go to thermal depolymerization, which goes down to the hydrocarbon mix, and which, in a sense, these are different technologies, quite different from each other. and they also achieve different things and deal with different kind of feedstock. So first surprise was actually whether this makes sense. And I know that some industry doesn't think that solvent-based purification, precisely because it's a polymer to polymer process, that should not be qualified under chemical recycling. But that's, for me, just one more reason why actually we need some clarification as to what it is and what is not chemical recycling. What we also found out is that when looking at the companies that are working on this, we saw that the technology is not yet mature, in the sense that despite having some pilot plants here and there dealing with some 10,000s of tons, etc., we don't have plants working at scale yet. And from our research with stakeholders, we saw that it was expected that between 5 and 10 years were needed to get like significant capacity in place. This is not a plan that you like set up in 6 months. I think that between getting the investment, the permits, the construction, and getting into operation takes time. And also, you need to have some sort of control about the volumes that you're going to manage. And this is also not very clear. We also found out that the costs and energy, the costs of the whole different processes is not very available, or at least that's not very known. The same is true for the energy and mass balance of these processes. We believe that, of course, that is going to come little by little, but considering that the expectations were so high, we were surprised by the lack of information that was available for something that was actually coming with such a strong energy. It also deals with works with groups of monostreams, or sometimes different polymers together. But what is clear is that it's not technology that could deal with plastic pollution as such, as like mixed plastics as they come from sometimes beach cleanups, for example. And I think that was an expectation that needed to be explained as well. And also we were surprised as well to see that the industry itself was not united as what chemical recycling was. I mean, for the waste industry was a different understanding that from the oil industry, or from the FMCGs as well. However, I mean, we saw that it can have a place in a circular economy, because of course, if in the framework of an EU decarbonization agenda, in which the European Union wants to move away from fossil fuels, the plastic in the future needs to come increasingly from recycled content, bio-based materials, and also we need to use the plastic a lot more responsibly and hopefully use less of it. So from that perspective, of course, when chemical recycling can deal with that waste that is unfit for mechanical recycling because of being too degraded or too contaminated, because it's true that you cannot recycle plastic forever with mechanical recycling, that could find a place. However, we need to find this place. I mean, we don't believe that this is something that is going to happen spontaneously, especially when we put so big expectations. From an EU policy perspective as well, the study that we did looks a bit into that. And what we saw, of course, is that when you do plastic to plastic from chemical recycling, that fits into the definition of current definition of recycling. The plastic to fuel, because it's one of the other outputs you can make out of the chemical recycling process, would fit in the definition of recovery. There's also what we identified the third category of plastic that is not transformed into plastic, but also not into fuel, such as lubricants, solvents, etc., that we guess would fall into recycling. But however, what we're seeing also is that for the coming years, there's going to be EU funding going to finance chemical recycling. And it's still unclear whether that would be for plastic to plastic, plastic to fuels, plastic to materials, etc. And we think that clarity is needed in here. Also, something that we look at with concern is chemical recycling. It has the word recycling in it. So from a marketing perspective and from a consumer perspective, having something that is turning plastic into a fuel, so it's a plastic to energy, and calling it recycling, we don't believe it is in favor of actually making the public understand what we are really doing. So chemical recycling should be limited to recycling operations, and energy recovery then is something different. When we look at future-proofing chemical recycling, we are working in the scenario that by 2030, all packaging in Europe should be recyclable. And we believe that chemical recycling should not be used as an excuse to keep plastics in the market that are not mechanically recycled, but since they might be chemically recycled, they might still be allowed to be produced. We believe that first they should be mechanically recycled, and if they cannot, then it should be chemically recycled, but not increasing the number of polymers out there. From a climate perspective, we wonder also what sense does it make to turn plastic into fuels in times where actually the oil, especially fracked hydrocarbons, are quite low in price, and when the energy coming from renewable sources is getting cheaper and cheaper. So in a highly decarbonized energy mix, we believe that plastic to fuel, it's just still more carbon intensive than other renewable energies. From a circular economy perspective, we also wonder how can plastic produced via the chemical recycling be competitive in an open market that is competing for cheap hydrocarbons. I mean, today what we're seeing is that we have very cheap hydrocarbons being exported from the US into Europe, which is going to be produced in plastic at very low cost. And we wonder how is that going to impact chemical recycling when potentially this might be more expensive. And I guess that's something that also Carlos could well in his presentation, because it's something we also wonder. And last, we also worry about that chemical recycling is only going to be profitable via EU subsidies, and we want to avoid being in a scenario of biofuels story 2.0. It's important that chemical recycling has its place, that it's complementary to mechanical recycling, but that we don't lock ourselves into this technology just for that. So to conclude, the recommendations from our side is that I think that we need a clear definition of chemical recycling that excludes any operation that does not result in the production of building blocks of high quality material. And again, if we're calling it chemical recycling, I think it's important that we do recycling and we don't do energy recovery, because that is a problem from a communication perspective and from a clarity perspective. That only processes with a lower carbon footprint than the production of plastic from virgin feedstock can be classified as chemical recycling, because the carbon footprint of these processes also matters. It's not just because it's recycling that it's good, it also needs to make sense from a carbon footprint perspective. And also that to limit chemical recycling as something complementary to mechanical recycling. So as I said, to deal with degraded plastics or contaminated plastics, we believe it has an impact. In our zero waste hierarchy, that in a way is complementary, but if we see that it's a bit step beyond the EU waste hierarchy, what we see is that recycling, composting, and anaerobic digestion should deal, that's the fourth level of our hierarchy, should deal with high quality material recovery from separate collection waste streams. Whereas material and chemical recovery or chemical recycling, for us, it deals with something that should be at a lower level, not because the output is of a lower quality than the output of mechanical recycling, but because the feedstock, the plastic that is separately collected, we believe should be first mechanically recycled, and it should be clear that then only the discards, the degraded parts, are going to be chemically recycled and not go straight into chemical recycling, because otherwise we run into a competition in this front. And finally, so we would suggest to have this new level in the waste hierarchy. If we don't manage to have a real differentiation between chemical recycling, which it means plastic to plastic, plastic to materials, and plastic to fuels, that for us should not be chemical recycling, should be energy recovery or whatever we want to call it, but it's important to draw a clear line there. And finally, for coherence with EU climate and circular economy agendas, we believe that the European Union, when looking at funding and subsidies, etc., this funding should only be allowed to finance, again, plastic to plastic chemical operations, because that's in line with the EU climate and the EU circular economy. Plastic to fuels for us is a way to actually could become kind of a loophole within the circular economy, and that is something that we should avoid. And as a conclusion, there is a need for clarification in the role that chemical recycling has in a circular economy. It is clear that it's not the solution to plastic pollution. It is definitely part of the solution to make plastic circular, but the solution to plastic pollution is a lot more complex. We need to go upstream. We need to redesign business models and products to be waste-free by design. And that's, for us, the real solution. And that's my presentation. Thank you so much.
Great. Thank you, Jean-Marc. That was, yeah, fantastic opening to the discussions today. And as you mentioned before, there is a Zero Waste Europe study, which has been linked in the chat box previously. So do take a look and read about our research in more detail. We have a couple of questions already submitted for Jean-Marc, which is wonderful. So I guess maybe first we'll take this first one from Ashley Sonsolet. Jean-Marc, the question is, are you able to provide examples of monostream and polymers in terms of within consumer products or other at this stage? And then there is a second question, maybe we can take two at a time, around mechanical recycling. Most of the time leads to lower quality materials, so downcycling. If chemical recycling brings a solution to that, then why avoid the competition with mechanical recycling? If you're happy to take those questions.
Yes, thank you. I didn't understand the first one, so if you can maybe type it while I'm answering the second one. It's true that both mechanical recycling and chemical recycling can potentially compete for the same feedstocks, and one could argue that actually makes sense because it could drive prices down. The thing here is we have a waste management system in Europe that is working, that is set up, that's where separate collection is designed today within a framework, and where there's a capacity to deal with a mechanical recycling. I think chemical recycling, if that enters the market, I think it's going to be an issue for the capacity that is in place. And I think that's why it's important that we, from a kind of structural perspective, we see chemical recycling like taking space, but not from a competition perspective, but actually from a complementary perspective. Also because mechanical recycling, it's a system that is more, I would say, it's cheaper to implement, and it already has economies of scale that chemical recycling doesn't have today. So, and the other question was about examples for monostream and polymers in terms of consumer products or other. Meaning, like, for example, like PET bottles that are monostream, or like what? I don't really understand the question. So in the packaging industry today, what we see is that there's lots of monostream packaging from a plastic perspective, but there's also like a multi-layer packaging, for example, has different layers of sometimes different polymers. I mean, I don't know if that's a question. I don't want to spend time into something that I don't really understand. Sorry.
No, I think that's great answers to both questions. And yeah, maybe the first one perhaps is we can, if you can submit your question again, Ashley, if it wasn't answered properly, that'd be great, because then we can come back to it later on during the webinar, during the final 30 minutes or so at the end, hopefully for a broader Q&A. And so take a couple of more questions here for Jean-Marc, whilst possible. One from Stephen Short around Zero Waste Europe's narrative on chemical recycling. So he mentions any innovative program, industry needs positivity to develop. And then how does Zero Waste Europe suggest industry work on innovation, whilst we have a lot of negativity perhaps towards chemical recycling? And then a lot of questions coming in here, but I will take one so we've had one from Mauricio Kripa, who says, why have we highlighted the fact that chemical recycling cannot work together with mixed plastic, and sorting is working very well? And then maybe I will use my privilege as the sort of moderator here to broaden that out, talking about sorting, whether it'd be great to learn a bit more about what you think the local level enabling environment, the sort of what the requirements needed on the ground within municipalities to support any successful implementation of chemical recycling. That's okay.
Yeah, thank you. So yeah, thanks for the questions. About the first one, I wonder if this study seems as like being negative to chemical recycling. What we're trying to do here is like shed some light into something that we thought it was exaggerate to present this as the solution. We believe that this has a role to play, but we need to find a way to that it fits into the circular economy. And the way to do that as well is to have the right information. What we realized is that there were discussions being organized, there was actually investment being mobilized, but it was not clear, actually, not even the costs of these operations, the energy balance, the mass balance. So we are all in for innovation. I mean, for us, the real innovation needs to be in actually how do you design systems so that they don't generate waste at the end. The current system based on single-use plastics, it is just like trying to optimize product once it has become waste. It's going to be insufficient to have a circular economy. The way we manage plastic today and we use it is very inefficient. So that for us, that's why the solution is really upstream. Now, when it comes to downstream, of course, if plastic needs to be there, when it's not possible to avoid it, it needs to be recycled. And for the plastic that it cannot be recycled after 4 or 5 cycles, then it can make sense to actually use chemical recycling. So we support innovation, and we are in favor of actually closing the loop on plastics. I mean, we don't want plastic to end up in the environment. We don't want plastic to be used for things that are not necessary. On the question from Jack, we believe also that when it comes to the requirements at the local level, today in Europe, there's a very big room for improvement in the separate collection of plastics. As probably most of you know, only 1/3 of plastic packaging in Europe is separately collected for recycling, and the separate collection is still not of very high quality. So actually, what we are worried about is that precisely because this separate collection is not of very high quality, that this mix of plastics, we're going to find a way to actually deal with them as a mix and and stop kind of separating it. And we thought that would be wrong. In this sense, we support like initiatives like it's introducing deposit systems, going back to refillable systems as well, so that packaging can be used several times, and like this increase the material efficiency, etc. If extended producer responsibility schemes, we believe are very important for this, and the eco-modulation of fees would actually play a role in simplifying the complexity of the plastics that go into packaging, therefore making it easier to separately collect it and making it easier to have it mechanically recycled. What we believe is that we cannot, with the current system, adding chemical recycling would be the wrong thing to do. We need the current system needs to be optimized. We need to simplify the packaging out there. We need to have polymers that are more recyclable, and then chemical recycling can play a role. But let's not start the house from the roof, in a sense that chemical recycling needs to deal with a system that has been optimized, with packaging that has been designed, with toxics, with simple polymers that actually make it the whole process afterwards easier.
Perfect. Thank you so much, Jean-Marc. That's really interesting, really useful content for us, and I hope everyone on the call has appreciated that, as well as enjoyed first sort of third of the webinar now. We're going to move on to our second speaker. And just a quick reminder as well for participants to submit questions for our speakers in the specific Q&A box rather than the chat box. That would be great. So now I'd like to invite Carlos Monreal, the CEO of Plastic Energy, to present. And Carlos has significant experience as a CEO engineer training. He's been a serial entrepreneur for more than 30 years and was a founder and CEO of Inland Geo, a company that supplied high-tech electronic instruments and turnkey solutions in multiple industries for 24 years, and later became president of Abyssal for a further 7 years. This company offered consultancy and EPC solutions on both renewable energy and efficiency. And Carlos is also the founder and CEO of Greenland Capital, a company with the vision to identify and develop disruptive technologies that provide sustainable and economical solutions to the growing challenges of waste, water management, and alternative management too. So we're really lucky and privileged for Carlos can join us. So I will hand the floor over to you, Carlos, and yeah, invite you to share your screen and presentation.
Well, thank you very much, Jack. Thank you, John Mark, for the first presentation, and really much appreciated to Zero Waste Europe, the report, the study that has done, and since I have, let's say, the only 10 minutes to present, and I want to leave time for questions, I'm going to directly dig in. It's not moving the picture, the slides. Yes, no. Okay. So in the here we can say these days, yes, we have a long way to go in Europe for recycling. You can see a few high-level numbers summarizing the recycling situation in Europe, where we say that there is something like about 27 million tons of plastics collected, but in reality, less than or something like about 8 million tons are being considered recycled, which means 31%. However, out of these 8 million tons, something like about 5 million tons are really being recycled within Europe, and the balance is being exported. So to countries that they have very little infrastructure and to manage this waste, and that is really becoming a big burden for them and a pollution to all of us. And that is particularly into Southeast Asia. That is why we believe that in the European context, it is essential to improve waste management, which means adapting the collection and sorting to current recycling technologies, but also to the ones that have been proven and are currently being developed. All this, of course, with the ultimate aim to increase recycling, to make the most of resources and to divert the resources towards the highest possible option in the waste hierarchy. And for us, it means diverting many plastics away from incineration and landfills for it to be recycled. Chemical recycling is part of the solution, but of course it's not a silver bullet. Okay, reaching the goals doesn't imply only one solution, but instead many solutions working and developing jointly. We fully understand and 100% support the fact that reduce, reuse, working, and better eco-design are essential actions that should be adopted by the industry and the population. However, we also don't believe that it cannot solve the full problem. That is where improvement in mechanical recycling and the development of new recycling technologies such as chemical recycling also played an important role. I want to put the presentation in this context, where we are trying to bring a solution on the table. It is not the only one, and the full solution will be a mix of multiple complementary solutions. As a technology company, we are here to discuss specifically chemical recycling. Why chemical recycling is part of the solution? Is that we know that the Commission has set some targets in two areas: recycling targets, with 55% recycled plastic packaging being recycled by 2030, and recycled content targets, but limited to bottles, where we expect, however, targets to move into a similar direction for all plastics packaging, and why not, for example, to the automotive industry. Why do we have to focus only in packaging? Brands have also made commitments to improve recyclability and recycled content. They have often committed to have 100% of their plastic packaging recyclable or compostable, and an average of 30% recycled content. Chemical recycling is a solution, given that it supports both the increase in recyclability and the increase in recycled content to reach these commitments and targets. On the one hand, we take a broader and complementary range of plastics than mechanical recycling, which means it prevents some pollution, lead to more recycling, and move one or two steps higher into the waste hierarchy. On the other hand, we enable the inclusion of recycled content in food-grade packaging, which has so far been mainly limited to PET bottles. Our position is chemical recycling complements mechanical recycling. On the left side, you can see that mechanical recycling requires homogeneous and clean waste streams. It is expected to improve, but not to reach the recycling targets or capture the full plastic waste stream. Given the safety required by food-grade packaging regulations, the recycled content produced by mechanical recycling is often used for lower applications, often called downcycling due to problems of, for instance, quality, potential contamination, aesthetics. So therefore, it is still an essential application, but not always adopted to food-grade applications. Chemical recycling overcomes some of the limits of mechanical recycling by taking different types of waste streams, at least for some technologies, with some contamination that will either be technically challenging for mechanical recyclers or not economically efficient. Given that its expansion has just started, it is expected to grow substantially and could recycle 17% of plastics globally by 2030. It also has the advantage of endlessly upcycling to food-grade applications. Looking to this process more graphically, we see that for traditionally recyclable plastics, the yellow loop is well established. What we are trying to do with chemical recycling is to avoid the red arrow, to avoid the waste plastics going into the leakage or going to the landfill or incineration, by creating a blue loop to complement the mechanical recycling loop by diverting non-mechanical recycled plastics that currently go to incinerations or landfill or leakage. Chemical recycling exists. We heard from John Mark that there are no plants working at a scale, and this is something that is, I want to take this opportunity to invite the Zero Waste Europe to visit our plants. You can see on the right a picture of one of our plants in Spain. We currently have 2 commercial plants running for the past 3 years, currently running 24/7, 330 days per year. Together, they are processing 30 tons of plastic waste per day. So chemical recycling, we can say, at least from our company point of view, is a proven technology. We are now expanding and upscaling. We expect to have 20 plants finalized or in construction by 2023, and with each one of them processing 75 tons of plastic waste per day, or something like about 25,000 tons per year per plant. What is the feedstock that we can use? You can see on the right side of the screen the type of material or feedstock that we are processing. That material, it will be extremely difficult for a mechanical recycling technology to be able to be processed. We take post-consumer plastic waste coming from the reject of recyclers or waste management companies. We do not need to separate, we do not need to wash the plastic waste. This doesn't mean that we can take everything. We have some specifications that are being reached through a pre-processing to remove some of the contaminants and limits the plastic from the right column. The column on the left represents our ideal feedstock for chemical recycling. In our technology, mainly we heat the plastic at high temperatures in absence of oxygen, so there is no burning, until it melts and creates hydrocarbon vapors. From this process, 3 products are created, mainly a liquid fraction, which is what we call taq oil, which is being used as a feedstock to make new plastics. A synthetic gas fraction, which is reused in the plant to replace some of the gas and electricity needed to power up, and then char, which is the byproduct of the process representing the original contamination and is sold to the construction industry. The product that we produce is taq oil, is being used by the chemical industry to make new plastics or chemicals. Given that each chemical company has its own specification for a product to enter into its cracker, each plant we build will provide taq oil for one specific client, according to their own specifications. The taq oil will then be directly replace the virgin oil in the cracker. Depending on their infrastructure, some will be able to use the full taq oil to make new plastics. Others will have to use the naphtha fraction to make plastics, and the rest as alternative fuels. Given the high demand for recycled content from brands, to reach their commitments, there is a real demand and a market incentive to make new plastics. Our aim is very much to focus on producing a feedstock to make new plastics. We are the first company globally to have validated the circular economy with this process. It has been announced in Davos in January 2019, and it has been certified by the ISCC. For this certification, ZWE, is a waste management company based in the Netherlands, has provided the waste we have transformed into recycled oils to feed SABIC cracker in the Netherlands, created recycled content for the food-grade packaging of Unilever, the Bensons, and Walkie Group. With this process, we can endlessly recycle end-of-life plastics into food-grade packaging by replacing virgin oil. Some real examples of food-grade packaging that you can see on this slide, where these food-grade products with recycled content from our process are now on the German, Spanish, and Dutch market for the Magnum pot. The Nord pot is available in France. The plastic-to-plastic process is now a reality, validated, certified, and on the market. The product with recycled content were exposed at the K Fair last month in Düsseldorf. Is chemical recycling really recycling? Following this example, we can ask the question, does chemical recycling really recycle? If we look at the definition of the European Commission on the left, it is technology neutral, and we do not have to differentiate between technologies, as long as it is reprocessed into products, materials, or substance, and not into fuels. So there is no distinction in the definition between mechanical or chemical recycling. What matters is the final use, which will define whether it fits under recycling or energy recovery, as you can see on the right side. So yes, plastic to feedstock is recycling. However, there are some policy challenges. Although policy is going in the right direction, there are still some points that need to be clarified. For instance, the inclusion of plastic to plastic in the recycling targets. If it is recycling, why not to incorporate it and to include it within the targets? Or the official clarification on whether recycled content from chemical recycling can be used in food-grade packaging. We believe that there should be some incentives to move a step above in the waste hierarchy and divert the plastic that can be chemically recycled away from incineration of landfill. We also support policies aiming at less export of plastic in order to develop the recycling infrastructure locally to manage the waste. More needs to be invested in R&D to improve the process or apply it to different types of plastics that cannot be mechanical recycled. So our mission as a company, overall, chemical recycling will prevent some pollution. Increased recycling contributed to improving the circular economy of plastics and reduce the need for virgin oil. In this framework, it is also part of our mission to develop, as asked by the industry, policymakers and NGO, a life cycle analysis to assess the impact of chemical recycling. There are already some LCAs providing a good indication of the impact of chemical recycling, such as the CE Delft, but we understand that it is important to have some LCA based on existing commercial plants, and that is what we are currently developing with an independent assessors. Jack, this is my presentation.
Wonderful. Thank you so much, Carlos. Really, really interesting, fascinating slides. And just to confirm with everyone that we will share the slides with those who've signed up, so you will have them to digest in your own time. So yeah, and Carlos, we've had a flurry of questions come in for you. I hope that's okay. I think maybe we'll go one at a time, if that's okay, because they're a bit technical, and so I don't want to bombard you too much maybe with this stuff. But yes, perhaps we can begin with this one from Catherine Miller here. Says, thanks, Carlos. You tell me if there was types of plastics unsuitable for chemical recycling, and the solution to disposing of those plastics that are not suitable. Sorry, we can start with that.
Yes, it's in our chemical recycling has different type of technologies. I'm going to be talking mainly of what we do at Plastic Energy, but chemical recycling can treat different type of polymers, different type of plastics. In our case, in Plastic Energy, we are focusing in the end-of-life plastics that are all type of plastics except PET and PVC. All the other type of plastics, we can process it. We don't have to separate it by type of plastics, and we don't have to wash it.
Great, thank you very much. Yeah, I'll get one more question if that's okay. And then this is a broad one from Marianne Bigum. Is you mentioned the 2 commercial plants that you have up and running in Europe, and maybe it'd be great to give a bit more information about the outputs of these 2 commercial plants, so the energy, and what are you using this for, and perhaps a bit of information about the costs that these plants have been running at, and also maybe the mass and the balance of the energy that's being outputted.
Yeah, I think I fully agree with John Mark. That is the situation is that there are not a lot of information available, and this is something that this type of technologies has been or the core of the technology has been in the marketplace for many, many years. It's been more than 20 years. What we have done is to really integrate different type of technologies in order to be able to provide one single solution. But I'm very happy to to take this question and this comment from Jean-Marc and your question to be able to answer some of these questions. We have a couple of plants in Spain. They are operating, as I say, 24/7. Has been a challenge. Has been operating since the last 3 years. It was very difficult to operate the plant the first year more than 230 days. To move from 230 days to 330 days, 340 days has been an extreme challenge, but we have been able to make it happen. There is a common perception that these type of technologies are highly intensive of energy consumption. We can say it in our situation is we can process the end-of-life plastics with the synthetic gas that we produce out of the process. So we will be completely energy neutral in that part, and we consumed energy only to a process that could be very similar to mechanical recycler, which is we use extruders, and those extruders are run and operated by electricity, and that is the consumption that we have, plus then some other electricity consumed later on the utilities of the process, on the complete overall process. But let's say that the chemical recycling process itself, we can make it energy neutral only with the synthetic gas that we produce on the process. In terms of the mass balance, you could check out in internet everybody within the chemical recycling industry or pyrolysis, everybody say exactly the same thing, which will not make any difference. Out of 100 kilos of feedstock coming in, everybody says that they converted into something like about more than 80 liters of output, and that is because of that is mass to volume, because of the density of the final products. And the cost of one of these plants is our technology is modular. We can process different modules, different capacity of the plants. However, the right optimal size of one plant for our technology is to be able to process between 20,000 to 30,000 tons per year in one single plant. That means, let's take 75 tons per day, process it. That will mean 25,000 tons per year. And that will have a cost of something like over 40 million euros for a complete solution.
Wonderful. Thank you so much, Carlos. Really interesting stuff. Appreciate your expertise and sharing your experiences and what Plastics Energy is doing. So we'll end your Q&A there, Carlos, if that's all right. Thank you very much. Now head to the third and final speaker of the webinar, Rosalina Petrova, who's a policy officer, waste management and secondary materials unit at the Directorate General of Environment, the European Commission here in Brussels. Rosalina joined the DG for Environment in 2010 to work on the European Union's transition to a resource-efficient and circular economy. Rosalina is also responsible for sustainable development, green jobs, and mainstreaming of environmental policy in economic affairs. Since 2015, Rosalina has been working on policies to increase the recycling of waste and to use it and its use as a raw material. So extremely relevant, important to discussion, and we're really excited to have Rosalina join us today. And I believe we have the presentation ready to go. So Rosalina, I will hand the floor over to you for your 10-minute presentation. Thank you very much. Rosalina, you might be on mute, I think, still, if you're still there. Oh, sorry, Rosina, we can see you, but we still can't hear you. Yes.
Yeah. Is that okay?
Yes, perfect. Go for it.
Yeah. You're going to show my presentation, right? Because I get some problems with the Commission computer. I can also share my screen, but
no, don't worry, don't worry. We have the
but you can play the presentation,
up.
right?
Yeah, yep, it's up on the screen now. Thank you.
All right. Okay, great. So first of all, I chose for the title of my presentation, chemical reprocessing of waste, exactly because of the reasons that were already mentioned, that the chemical reprocessing of waste refers to a number of technologies, some of which indeed turn waste into new materials, and some of which yield also substantial amount of fuels. But what I would start with is actually, you'll find it on the second slide. And this is how does plastic use and reprocessing looks like in a circular economy, where we would like to keep the value of products, materials, and substances of our resources for as long as possible. And there you'll see indeed the waste hierarchy that you also showed on your slides of Zero Waste Europe in another depiction, actually, that indeed the preferred route is reused, is reuse actually of plastic products. Then from the current available life cycle assessments, we see that mechanical recycling is more beneficial from an environmental point of view than chemical recycling. Then we go to various loops for plastics that include various levels of depolymerization, starting from indeed keeping the polymers to going to oligomers, to really going to the monomers, to the smallest parts. And this is very well explained in your report as well. And all these processes have their own let's say impacts and also their own benefits, and this is what we would also need to consider as we go. So if we go indeed to the next slide and to the definition of recycling that was already mentioned, it indeed it is technology neutral. So that's why the loops that we saw on the previous slide, they're more from let's say more from a life cycle assessment perspective than from a legal perspective, because as regards the legal perspective, any process, any reprocessing that leads into turning waste into product materials and substances could be qualified as recycling, provided that two uses of those product materials or substances are excluded, which is energy recovery or the reprocessing into fuels or backfilling operations. And of course, here what is important in the area of chemical recycling are the elements that relate to energy recovery and the reprocessing of materials to be used as fuels. So whenever this, as was already taught by the previous speaker, whenever this is the case, then we do not talk about recycling, but we would rather talk about recovery of waste. And we should also bear in mind, here we are looking into plastics, but when we look into other materials, we also talk about processes that are of different level of efficiency or environmental impacts. We should be aware that the reprocessing of metals, for instance, or glass have also their own impacts in terms of energy demand. So this is something that we always bear in mind in order to ensure that we are also fair among the various materials. So if we go to the next slide, we'll see what drives actually all the efforts in increasing chemical recycling of plastics. First, we have the packaging waste recycling targets, and with the new waste legislation that we agreed in 2018. We agreed on quite ambitious targets for packaging. You see the current target is 22.5%, and it is formulated in a way that what should be taken into account is only reprocessing plastic back into plastics. The new targets are increased to 50% in 2025 and 55% in 2030. When we were developing the targets back in 2012-13 is when we actually performed the impact assessment. What has been taken into account for these targets was actually mechanical recycling, and that is why those targets are also somewhat lower than the targets for other materials. For instance, for all other except for wood, which is a particular case, we have higher recycling targets. And for plastics, it was considered that with current technology at the time of the impact assessment, which was mostly mechanical recycling, these were the optimal levels to be achieved. Of course, the Commission proposal was a bit higher, but well, this is the result of the negotiations. And of course, we see now a lot of efforts to indeed increase the recycling of plastics, and it is because of the target, but it is also because of the calculation rules. And on the next slide, we will see actually what is the point of calculation for recycling, and this is when waste actually enters the recycling operation. So basically what is currently reported in many cases is what is separately collected or what is sorted, but especially for plastics we know that there are a lot of losses between separate collection and input to recycling, and now the point of recycling is moved to at the point where waste is actually reprocessed into product material and substances. And on the next slide, we can see that as regards mechanical recycling, this point has been decided together with all the member states that it should be the point before the pelletization. So at the moment where the plastic waste is clean enough, divided by polymers, and in the moment that is actually turned into new products and materials, it's the point before the pelletization. And at that point also, if we consider packaging waste, it is the point where it's comparable to the packaging, the plastic packaging that is placed on the market, which is also dry. I mean, when it's weighted and producers pay EPR fees for it, it is dry and it doesn't include any contaminants coming from the products that it contains. So, but here indeed this flow has been developed with mechanical recycling in mind. But when we develop the calculation rules for recycling, we have also thought about new emerging practices, because we are aware that chemical recycling as such, it's not an emerging technology as such, so it has been around for quite some time. There have been reasons for not taking it up more widely, but for new technologies that may potentially combine energy recovery and outputs that combine recycled materials and fuels, we have defined a particular rule, and this rule I think we will be able to see on the next slide. So the next slide talks about the case where we have mixed outputs, as I said. So the materials are not principally used as fuel, but they are also not mainly subject to material recovery. So they are these mixed outputs. And at that point, the calculation, so the contribution to the recycling targets should be determined on the basis of a mass balance approach, which results in taking account only of waste materials that are subject to recycling. So this is what has been decided as a general rule. And of course, when we talk about chemical recycling, we have to consider that that this rule may be too general, and once that we study more in depth the various processes, we may decide that we need some further clarifications on how this is going to be actually implemented. But we are also still looking to see, indeed, as you said, examples of mass balances and of energy needs and so on and so forth. So that is something that we may still need to look further into. So when we go to the next slide, please, you'll see next to the packaging targets that I just mentioned, what are the other drivers of developing chemical recycling from EU perspective. And this is indeed the EU plastic strategy that indeed aims at making all plastic waste reusable, or all plastic, let's say, packaging reusable or recyclable by 2030. We have also the directive on the reduction of the impact of certain plastic products on the environment. This is the so-called single-use plastics directive, where it includes binding targets on recycled content, and we have indeed the targets for minimum recycled content in PET bottles and in all plastic single beverage bottles. And this is also one of the reasons why chemical recycling is looked at it with an increasing interest. And here we are indeed talking about the food contact materials, which is still another separate stream of legislation, but it's also linked to the single-use plastic directive. And there, indeed, the requirements on food contact materials are very high. And there, for instance, we have recycling processes for now approved or in the process of approval, rather, only for PET. While for other plastic materials, it is still a challenge to turn them back into food contact materials. Of course, for certain plastic, this is possible through closed loop system, but for many of the other plastic, this is still a challenge. And when we consider how big the demand for food contact is, we see that there is innovation needed, whether the solution would be purely chemical recycling or a combination of design and many other measures. That we still have to see. And we indeed, in this respect, we would like to encourage the complementarity of various actions. Indeed, mechanical recycling has its place, its environmental benefits, and at the same time, we indeed we see a certain role of chemical recycling in achieving the targets that are set by the plastic strategy. 10 million tons of recycled plastic, and also really closing the loop of plastic in a circular economy. And then another important development that has to be kept in mind here is the discussion on the current ongoing discussion on the own resource for the EU budget, which is based on non-recycled plastic packaging waste, which again would give stimulus to increasing the overall recycling of waste. And indeed, then if we go to the next slide, we will see the future development that would again provide incentives for increased recyclability, and also will pose some serious questions as regards chemical recycling. packaging. So this is the review, the ongoing review of the essential requirements for packaging, where indeed we would like to make sure that all plastic packaging is reusable and recyclable in an environmentally and economically efficient way. At the same time, we would also want to work on waste prevention measures, on reduction targets, and there, indeed, again, plastic packaging has quite high profile. And we should also indeed see all the development technologies in the framework of the future task that the legislators have given us to review the packaging waste recycling targets at a certain moment. Because if we see also indeed mass developments as regards chemical recycling, given the current recycling targets may be somewhat too low. But these are all kind of future quite long-term developments, but I just wanted to put them also in this context. And this is actually my last slide, and I would be delighted to answer some questions. Thank you.
Thank you so much, Rosalina. That's really interesting, and I think it's added a lovely supplement to the discussions that's been ongoing already throughout this webinar. So thank you very much, and we know how extremely busy you are, so appreciate your time and for joining us today. We have not a huge amount of time left, 18 minutes or so, and we can extend it a tad. So I'll get started. Maybe we have a question for you, Rosalina, and we can open it up to Jean-Marc and Carlos as well. And maybe we could start with this one from Kimberly Chan. I was wondering, Rosalina, in the work that you've done at the Commission, we've discussed life cycle assessments previously here, but have the Commission or for your partners done an assessment of chemical reprocessing recycling compared to mechanical recycling, specifically on greenhouse emissions and the sort of the impact it has on the climate and compatibility with the EU's climate and carbon targets as well?
Well, as I said, we have not done specific impact assessment on chemical reprocessing of plastic waste as such. In the past, I'm aware that there have been some studies on gasification and pyrolysis as such, but we are also aware that the technology is advancing and has advanced, and actually this would be something more to consider for the coming year or years rather than something that we have already available at hand. We are aware that indeed the industry is already working on impact assessment, so we will be very interested to review this, scrutinize it, and perhaps do our own work on this in the future.
Great, thank you very much, Rosalina. So yeah, maybe I will sort of ask Jean-Marc and Carlos to feed in now to the conversation, and whether, okay, we'll go over one question first, and there is a specific one here from someone at IGV regarding marine plastic litter. So this has been identified as a key source of priority for the Commission, mainly through the Single-Use Plastics Directive, and the question was posed whether marine plastic litter can be considered for testing within chemical recycling, and maybe I will open up to Jean-Marc first, and then to Carlos to specifically answer about his the plants that Plastic Energies does as well, and then Rosalina, you've heard there, and then of course invite the speakers to feedback any broader views that they might have on the other points that have been made by the other speakers. So Jean-Marc, if I open the floor to you first.
Yeah, very quickly, when it comes to marine litter, we believe that, well, of course, this is plastic that should not be there in the first place. And we don't want to see that actually that what we're trying to do is clean up the ocean and find ways to recycle what is in the ocean. What we need to do, first of all, is stop littering. And that should be the #1 priority. And then whether we collect ocean plastics and try to recycle them, that's a technical question that probably Carlos is more suited to answer. But again, it's important that we focus. The real problem with marine litter is littering. It's not that it's not recyclable. So actually, we need to stop littering, and the Single-Use Plastic Directive is a step in the right direction. And yeah, we'll leave it there.
Fully in agreement with John Mark. We do not believe in leakage. We don't want any plastic waste going to the oceans, and that is something that we have to avoid anyhow. It's not a question to clean up the mess that we have. We have to avoid plastics waste and general waste going into the environment 100%. That is something that it's not a question to really clean up what we have already created, because then it will continue going to the same place if we don't stop at source. So as a company, for example, we have an example in Indonesia, where we are really trying to avoid plastic waste going into the rivers and ending up into the oceans. And that's the way to go. And then it has to be recycled anyhow.
Mm.
Great, thank you, Carlos. Rosalina, did you want to jump in here?
Yes, please. So from our perspective, indeed, littering, there are many reasons why plastic ends in the ocean, and one of the main reasons is basically substandard waste management. Much of this waste actually comes from the fact that waste does not get collected in the first place, or arrives at substandard dumping sites, and then it's dumped into the environment. So solutions that as such increase the demand for plastic waste are welcome. This can come, of course, from increasing mechanical recycling. It can come from indeed increased chemical recycling, but basically improving the market for recycled plastics is one of the key issues in order to be able to prevent, first of all, the plastic waste leaking into the ocean. Currently, it has two raw value. It has limited recycling options, but it's not only the options, it's also the, let's say, the deployment of those options. So we would welcome, indeed, first ensuring proper waste management, and indeed, across Europe, in many cases, proper waste management is the case, and we are looking towards the next step of creating indeed the market for the secondary raw material and the demand for the recyclates. But in many developing countries which have severe problems with proper waste management, it's also as such, these solutions can also help to create demand for the plastic waste. And from this perspective, we are also interested indeed in broadening, expanding the demand for plastic waste. And well, whether what we fish out of the oceans by various cleaning initiatives could be used, it will depend on the, let's say, also on the level of disintegration into these plastics, but this is definitely not a solution. So how this cleanup plastic in the end would be used, it will depend on the quality, and we should always bear in mind that it will be very difficult to fish out all the microplastics that is out there, let alone to sort it. So this is indeed, I think that it's more via the demand that we should link these topics rather than on the use of the dumped waste.
Jack, if you don't mind, I want to add one just quick sentence to that. Is we keep talking about plastic waste in developing markets, but as Rosalina said, it is really a question of waste management. We see the detrimental effects of plastics because we can see the plastics waste. But what we don't see, plastics represents less than 15% of the domestic waste. So if we see plastics in the developing markets, we have to imagine what is happening with 85% of the rest of the waste that is leaking into the environment. So yes, we have to really improve the waste management in general, And as a consequence of that, it will help to really improve the waste plastic recycling, but also we'll have to find a solution for the rest of the waste, which is really becoming a huge problem in these countries. And if we can avoid and reduce the amount of plastic being exported from the USA and from Europe to developing markets, that will even help much more.
If I may jump just to complement, the issue of waste management, of course, it is a real one. We're seeing that waste doesn't have a value, doesn't get collected. That's why it ends up where it ends up. I would be careful with actually pointing the finger at the other countries for waste management, because I mean the truth is that there's products in those markets that are placed in the market, and there's no system in place to manage those products. And that is true also in Europe. In Europe, we're putting in the market plastics that we don't know how to recycle in the first place. So, and here we have waste management, imagining countries where there's no waste management in place. So, I mean, of course, then there's responsibility from the companies that put the product in the market. There's the responsibility to pay for the collection. So it's a complex issue. And I think it goes beyond waste management is key, but it requires also producer responsibility, and it requires also legal frameworks that can be enforced. And if we struggle in Europe, I mean, the rest of the world, I'm sure this is not doing a lot better.
Great, thanks all to the speakers. We'll do maybe another quick round. We'll start with you, Rosalina, because there's been a couple of questions here sort of specifically for you, and also mentioned in building on what you mentioned on food contact materials. So we, one from Michael and from Fernanda, specifically the market gap for recycled food grade plastics. Do you think this could be something filled by chemical recycling? And secondly, on how does sort of chemical recycling more broadly fit within the EU's existing laws on plastic food contact materials, where there's a positive list already for chemicals that are permitted, and also separate list of law on what recycled plastic materials. So how does chemical recycling fit in with the EU's food contact material policy? If we start with you, Rosalina, then bring in Jean-Marc and Carlos, or we can answer one of the many other questions going through as well. So Rosalina, over to you, if that's okay.
Well, indeed, we have DigiSante dealing with food contact materials, and indeed, I'm not the expert to speak on that, but as such, as a general line, we see that chemical recycling can have a contribution to, indeed, closing, as I said also during my presentation, closing the loop for plastics, in particular when food contact materials are concerned. We see that for PET, there are mechanical recycling processes that are approved for turning back into food contact. But again, there on the waste management side, we have to ensure that there is, let's say, quite strict a chain of control of that waste, in order to ensure that there are no contaminants, because we can imagine that if the quality of our of the materials in which our food is packed is put into questions, this can actually quite a lot damage the recycling market. So we have to ensure that indeed what is turned back into food contact material is of high quality, and there both chemical and mechanical recycling have a role. But indeed, for materials other than PET and for some other plastic that is kept into closed loops, it is very challenging to turn them back into food contact. But currently, I don't think that we can speak about the current market, because it's quite underdeveloped. So what we see as important is to provide the incentives both for mechanical and chemical recycling, so that they can find their places, complementary solutions to this issue. Thank you.
Thanks, Rosalina. Carlos or Jean-Marc, did you want to add in any thoughts on food contact materials?
I think we have proved already. Was announced the Magnum product a few weeks ago. Is the produced out of our process do not differentiate at all versus any plastics produced from fossil oil based. So it's only a question to, like John Mark was saying in his presentation, it's a question to really have more information on the marketplace for the Commission, for everybody to understand what can be done and what cannot be done with chemical recycling. So it's a question of time. For us, it's clear. We have proven it is there's no differentiation on the producing plastics with a feedstock coming from our plants versus any other type of feedstock used to produce plastics. So that is the situation. With the beauty that is we recycled endless the plastics that are going to be used later on by the consumers. So that is mainly an important point. Okay, is in terms of there are many questions on the webinar that we can see. I don't know what is going to be the protocol later on to answer. There is one that I can see right now on the Canary Islands. Is we are hopefully going to develop and build a solution in the Canary Islands that is going to be an example of sustainability. It's a small island with a lot of tourists producing the waste plastics that cannot be recycled whatsoever, and ending into a limited space of an island with a high energy cost. And that is going to be a very interesting, nice solution that we will have in the market by end of 2021, beginning of 2022.
Yeah, and from my side, indeed, the issue of food content materials is a key issue, and finding secondary raw materials for this is key. And I would like to take advantage, maybe because I've seen also the questions to ask Carlos. So in the process of chemical recycling, what we see is that there's plastics, but there's also lots of additives in there, and also non-intentional added substances. What happens in this process with all these substances? Because that's a question that arises when dealing with food grade material. Do they stay in the process, or what? How do they disappear, or like where do they end up?
They unfortunately they don't disappear. So this is that's something that is a reality that is like in any industrial process. If you bring into the process the plastics that have contaminants, that have retardants, that have pigments, that have any type of things that we would love to somehow reduce to be incorporated into the plastics, we have developed a extensive portfolio of and the database of information of different, from colors to pigments, that have a big impact into the possibilities of plastics to be recycled, and not only mechanical recycled, but also chemically recycled. Because at the end of the day, if you don't remove these contaminants, they will end up later on with the final product. So through our process, we reduce this type of contaminants in order to produce an output that has the right specs for the petrochemical company to potentially use it as a feedstock into the crackers. That, as I said in my presentation, that is not very easy. That is very complicated, and that is something that we are working. Is not, I want to say, that is a final solution done, but is work in progress, but looking very positively. And then, however, just to answer your question, part of these contaminants end up into the what we call the char. So everything that is gasified, we try to, before we condense it and distill it into the final product, we try to remove as much as possible of the contaminants, and some of them end up into the char that has a different type of treatment than the liquid outputs that we produce that are going to be used as a feedstock for the process.
Great, thank you, Carlos.
Just quickly, we complied with all the environmental requirements. We've been monitored for longer than 3 years, and we comply with all the requirements that we have to comply. And as a company principle, we will not be producing, we will not be building or operating something that it will be somehow polluted the environment. We will not reduce the capex necessary to run the plants in order to properly, safely operate those plants and provide the right quality of the output that we have to use. Otherwise, we will not do it.
Great, thank you, Carlos, again. And yes, so maybe we'll just ask one final question for Rosalina. If you keep your answer short, maybe we can bring in Carlos and Jean-Marc one more time, because I think it's a very rich conversation. Rosalina, there's a couple of questions here for you about the Commission's work on how to integrate chemicals policies such as REACH, into the plastics recycling, handling the sort of toxic additives and hazardous materials within that. Do you think the Commission will have a strong chemicals component within the recycling targets? And I'm going to be very mean and also supplement that with a second question from Jane about the Commission is now sort of setting such high recycling targets. How is the Commission preventing this from leading to a shift away from reuse to focus solely on recycling? And then, yeah, as I mentioned, if maybe Carlos and Jean-Marc can have a look at the questions in the meantime and end with a final closing points as well for 1 minute each afterwards. So Rosalina, I hand the floor over to you, if that's okay, on those 2 questions.
This interface between the chemical products and waste legislation, of course, we have been working on it quite extensively, and this is work that as such would not stop, but as such I don't see the integration as such of chemical elements in the recycling targets. Basically, the recycling targets are about the amount of waste that has to be returned or used in the economy in a meaningful way, and that is what it's about. And of course, all the materials that we put back on the market, that they have to comply with the product legislation and with REACH. Of course, there are numerous discussions as regards indeed the limit values, and we are having these discussions because we are aware about indeed the tension between using recycled materials that may contain legacy substances and then indeed ensuring the clean cycles. And that's why our efforts would be directed towards indeed these clean cycles, that the substances are not there in the first place. And of course, technologies that can deal with those substances would have an advantage in order to ensure that indeed what is put back into the economy is as clean as possible. But like the direct integration of this, basically the possibility to recycle certain materials is taken into account when the targets are formulated as such. And indeed, this is a subject of related policy, but not as such of the targets themselves. So the targets take into account the possibility to return certain materials back into the economy. And then as regards the focus on prevention, indeed, we have heard also that the new Commission would have a focus on prevention of waste, and reuse is one form of prevention, but there are many other forms or initiatives that can be taken in order to prevent waste. And of course, the challenge that we will face there is very broad, because then we go into the product policy actually, and this is no longer a waste policy. The recycling targets are more about, let's say, what we do with the waste, how we collect it, how we treat it, and the waste area is quite regulated. Once that we go to waste prevention, we are more talking about product policy, and this is where this will be also one of the areas, let's say, that the Circular Economy Action Plan, the next version of it, will most probably look at. We cannot now know what exactly the new Commission would decide on this, but as such, it is not one or the other, it's one and the other, that we should try to reduce the waste, and we should try to make sure that our products are recyclable at the end of their life. But indeed, slowing down the circle is very important, as much as closing it, let's say. So this is something that that would continue to be a priority in the coming years. Thank you.
Thanks so much, Rosalina. Carlos, any final thoughts? I'll hand over to you, and then Jean-Marc.
Yes, well, I will say that is we normally been focusing pretty much the whole industry, the society, in targeting only the packaging or plastic packaging. However, I think it's going to be very important to also give an opportunities to other technologies to recycle textiles. That is a high consumption of plastics one way or another, and that could be something that there are very good technologies that will have to also be addressed, and they will have to be taken into consideration, because we are talking about chemical recycling mainly always focused in packaging. But what about the textile industry? What about the automotive industry? Those are two industries that are very important. For us, we are very, I will say this, we have an opportunity in plastics. The targets, if we are recycling in Europe 85% of paper and 75% of glass, or vice versa, and however the plastic and glass has 1/3 the price of waste plastics or end-of-life plastics, we believe that it will be really possible within if the industry gets together, as it is doing right now, and also with the whole value chain, that within a short period of time, we could be able to be in the same recycling rates than paper or glass. Should not be any difference to that. And that is something that is possible because the plastic has, fortunately, has close to 3 times the value of glass or paper. And to me, I want to finish, Jack, with a comment that in general, we don't see, and it's not a question that I'm defending right now with what I'm going to say on chemical recycling, but we have to be completely open and completely agnostic in how we are going to tackle the end-of-life plastic situation worldwide. Doesn't make any difference if it's mechanical recycling, chemical recycling, or whatever we want to call it, if we can really provide a solution that can use that type of material endless or many times. And if we only use, let's say, mechanical recycling content within packaging, there are different studies that will limit, if we would use it, let's say, more than 30% of the content within the packaging, it will limit the number of times that packaging will be reused once again, or could be, recycled. It will be limited to less than 4 times. So chemical recycling can really provide a great solution or a complementary solution, and it's going to be both solutions are going to stand because the economics are going to be driving one and the other, and there is going to be a market and a room, and it's not going to be a competition at all between both technologies. Today, it could be concerns. In 5-10 years' time, nobody will have that concern.
Thanks. And I think that we agree that the plastic challenge and the circular economy as a whole is quite a challenge, and it will require going beyond what we have been doing so far when it comes to the technology, but also when it comes to actually thinking processes. From that perspective, I mean, I wonder, I mean, that's maybe like an open question for the Commission, since the current plastic recycling targets were designed with mechanical recycling in mind, if chemical recycling, real chemical recycling, not plastic to fuels, because it's something also I think that we agree that we don't want to call chemical recycling plastic to fuels, because otherwise we're going to be perverting the language. I think chemical reprocessing might be, or just like recovery operations, that would make more sense. But yeah, would be an open question for another discussion, would be, are we looking then at increasing the plastic recycling targets, factoring in the chemical recycling? I think, well, that would be interesting, but I guess it's for another discussion. And just to wrap up, something that is linked to the last question to Rosalina. I think that we have quite a robust waste legislation in the European Union. And linking to what Jane has raised, we have very little legislation or enabling frameworks for when it comes to reuse and actually like finding a different way to use the materials that we have been using since the last decades. I don't think that we should be dealing with plastic use or plastic as a material from a waste perspective. We should be using it, looking at it from either from a material perspective or from a product perspective. I think the legislation in those fronts is today insufficient. But we look forward to continue working on the waste legislation to actually improve it and to make sure that real chemical recycling has its place in there. Thank you.
Wonderful. Thank you all so much. I think the fact that we have 67 people online, I know we reached a maximum of 100, and in fact, we've almost gone an hour and 45. This is the perfect complement and testament to the nature of the conversation, the expertise of our speakers, and the great questions as well. So thank you all so much. And I know there were a number of questions didn't get to specifically answer, so I apologize for that. We simply haven't got the time, but we will continue these discussions throughout and over the coming weeks and months. And a final few thoughts from us. The link's already in the chat box, but if you'd like to, if you're in Brussels and like to learn more about this, we're actually hosting an event on how municipalities and local level action can really help rewrite the story of plastic, taking it away from simply a waste management issues to prevention, use and repair and redesign. That's in, as I mentioned, in Brussels. 11 till 2 tomorrow. It's free, so do come down if you're in Brussels at this stage. If you want to learn more, actually get hands-on specific experience about how cities and municipalities are preventing plastic waste, and you can join us on our next study tour. This will be happening in 2 of Europe's front-running cities to tackle waste in Milan and Caponori in Italy. It's on the 9th, the 11th of December, and you can find a few spots, I think, remaining. So please do register and come join us then. And the next webinar as part of our Zero Waste Europe live series will be on the 12th of December, and it will be looking at food waste prevention. We've got a great lineup of speakers already secured for that. So thank you all so much for joining. Thank you to our excellent speakers. Thank you all for your excellent questions as well. And we wish you a good day, a good evening, or a good morning, wherever you are. Thank you all. Bye-bye.